Inside this refrigerator, at the temperature just a bit above absolute zero, in an isolation, there is a quantum computer. This has promising potential to change our lives drastically with its extreme computation powers. Are they just next generation supercomputers or something else entirely? Before we begin talking about their abilities, we need to understand the basic physics that is behind quantum computing. Let's do it today. What's up everybody, Vishwas here. Today let's decode quantum computing. What is quantum computing and why even there is a need of quantum computing? Few decades ago, computers were of a size of a whole room with a very limited computing power. But as days went, computers became smaller and smaller with increase in the computational power. Computer chips contain various modules designed for each specific task. These modules contain logic gates which are made of multiple transistors, and these transistors are made of a semiconductor material like silicon. Current industry standard for the sizes of these transistors is somewhere between 7 nanometers to 5 nanometers, and even 3 nanometers is upcoming. But soon it is going to reach its limits and we won't be able to shorten the transistor sizes after that. These transistors basically act like switches or gates which allow to pass electrons from one end to another end with certain voltage, and otherwise they block the flow of electrons. This idea creates the basic building blocks of any classical computer or a binary computer. The smaller the transistor, the lower the power consumption and higher the performance. But at present, the transistors are shrinking to the size of just few atoms. The purpose of them to block the electrons from passing from one end to another end cannot be served well. This is known as quantum tunneling. In a quantum realm, or at atomic or subatomic levels, physics works quite differently than the predictable world, and especially when the temperatures are close to absolute zero. As parts are becoming tiny and tinier, quantum physics is making things tricky. So scientists are using these quantum properties to their advantage and building quantum computers. So what is wrong with classical or binary computing then? Some problems like optimization can be solved when the numbers are small. But as the numbers grow large, it becomes virtually impossible for traditional computers to do these jobs. For example, there are 10 people in the room and I want to arrange these 10 people around the table. So there are 10 factorial ways to do so. This number is already over 3.6 million. Imagine there are 100 people in the room, how large will this number be? Classical computers can't just scale up exponentially, and there comes the quantum computing in the picture. So how do quantum computers are able to solve these kind of problems then? If the problem grows exponentially, we need something that can scale up exponentially, right? In classical computing, bits are the smallest unit of information and can take values either 0 or 1. But in quantum computers, there are qubits, which can take values 0 or 1 both simultaneously. Meaning the value at a time doesn't have to be perfect 0 or 1, but it can also be in between that range and represent any proportion of both the states at once. This is called superposition. If this is very clear to you, let's move forward. A qubit can be any two-level quantum system such as a spin of an electron and a magnetic field, or a single photon's vertical or horizontal polarization. And unless observed, a qubit is in a superposition of probabilities for 0 and 1, and you cannot predict which state it will take once you measure its value. But once you measure the value of the state, it has to fall to one of the finite states, that is either 0 or 1. But how does this give quantum computers an exponential computation power? Let me tell you. You can represent 16 different values with 4 classical bits and only one value at a time, right? But due to this superposition of quantum computers, you can be in all those 16 positions at once. So with quantum computers, you can represent 2 raised to n states at the same time, where n is the number of qubits. And this number grows exponentially with every extra qubit added. One more property qubits have is called entanglement. A close connection that makes each of the qubit react to the change in other state instantaneously, no matter how far they are apart. Which means when measuring just one of the entangled qubits, you can directly deduce properties of its partners without having to look. And both these phenomena make quantum computers exponentially faster than the classical computers. Even though it is fascinating, there are challenges to operate quantum computers. First of all, they are resource intensive. They require significant amount of energy and cooling to run properly. A dilution refrigerator is used as a coolant that keeps the temperature in mini-Kelvin. Mini-Kelvin is somewhere around minus 459 degree Fahrenheit or minus 272 degrees Celsius, which is even colder than outer space. There are some limitations of using quantum computing. First is interference. Even a smallest interference may result in the wrong computations. So changes in the temperature of coolants or human interference may result into wrong computation. Second is error correction. Like in classical computing, quantum computers also need error correction to protect quantum information. Even a single error in the calculation could collapse the entire computation. And third, it is output observance. After quantum computer is done with the computations, the results need to be observed very carefully. Otherwise, there are chances of corruption of the results. Let us talk about quantum supremacy now. American players like IBM, Google, Microsoft are already in the race of quantum supremacy. And not only these big tech companies but also governments of major economies like US, China, India, Germany, Japan are investing massively in the quantum computing field. Because there are n number of possibilities to achieve with this technology, and whoever wins this race will become a supreme leader with extreme powers. In 2019, Google claimed that it has solved the problem that will take thousands of years even for a world's fastest supercomputer. However, that resulted in a big controversy. Recently, physicists even have managed to create a holographic wormhole using a quantum computer. Isn't that awesome? Next question comes to our mind is that where can we apply quantum computing? One of the most unique applications of quantum computing is that of quantum cryptography, which majorly focuses on the key distribution part of the crypto system. The next usage could be in drug design and development. Drugs are usually developed via a trial and error method. This is not only very expensive but also a risky and challenging task to complete. This is where quantum computing comes into play. Next application could be in cybersecurity. Cybersecurity is of utmost importance for the fact that the number of cyber attackers are increasing with every passing day. Quantum computing is no less than a blessing here. Quantum computing with the help of machine learning can help in developing various techniques to combat these cybersecurity threats. Let us talk about very interesting thing, that is programming with quantum computers. Right now you can access, learn and do programming with quantum computers. Even though it is Python, it is a bit difficult to learn this coding style. Currently I am learning programming with quantum computers, and if you are interested, let me know in the comment section below. IBM for instance has already developed a library called Qiskit, using which you can directly interact and program on quantum computers. I will provide the link in the description. So in conclusion, quantum computers are not mature yet, but this technology has greater number of potentials. To be able to do massive computations, quantum computers need to incorporate more and more qubits in their processors. These computers might not even be in our hands anytime, and access to them might be just limited via cloud, but upcoming decades or two will be interesting to see the progress of this technology. Guys, keep learning, keep updating yourselves. The world is changing faster and faster. Do subscribe to my channel. I will catch you in the next. Until then, bye bye. Peace.